So in the previous conversation, we spoke about natural language processing. We introduced the new topic, and I hope we all understand the importance of NLP in AI and learning language today. So I think most of the stuffs that we are using, whether it is LLM, are the latest and greatest algorithms are generative AI. They are revolving around NLP. So they are a kind of they have branched out from NLP. Uh, so in the conversation we spoke about the overall evolution path, right? And we also spoke about how the content, how this program has been structured. We spoke about that we are done with ML, we are done with deep learning, right? We are now onto NLP, right? And from there, we'll move on to the LLMs and agentic AI. So the ultimate goal is that we reached to the level of agentic AI, right? But in the process, there will be a lot of problems that we are going to solve. Uh, the kind of skill set that we are going to build, uh, irrespective of agentic, irrespective of LLMs, all these branches, you can use them independently. And um, while you're working on some of the solutions, you will figure out that uh, it's important that they exist independently as well. When I say this, uh, today the place where we are standing, it is kind of very tempting because it's very easy. The moment you pass a problem statement to any of the LLMs, whether you are using ChatGPT, you are using Gemini, Anthropic, or any of these LLMs, it kinds of gives you a response, and the response is most of the times appreciated by the reader, by the consumer, right? uh, of course we are going to talk about LLMs when we reach that topic, which is going to be the next one in the row. But it is important that we understand that LLMs are, they cannot be used for everything, though they are able to produce the results, but they can be questioned on multiple aspects. And being from the implementation side or being from the leadership side, you should know that LLM has got a cost attached to it. So in case if you have data, you are doing some kind of predictions, you're doing some kind of revenue prediction for an organization, and if you pass loads of data, say in MB or GVs, to LLM, it is going to cost you a lot, right? So these models are expected to run independently. Um, it's important that we develop our skill set in them. And in any case, LLMs and agentic AI, they are a kind of extension to these skill sets that we are learning. So in this particular conversation that we are going to hold today, right? Uh, we'll cover a couple of topics, but the idea is that now we should change the texture of all this training. I want that you start building your own source code, right? You start solving the problems. If you are from the leadership background, if you are from the business background, you start thinking that, okay, in case if this is the kind of problem statement that has been given to you, right? And there are a lot of hypotheses that you can do. There are a lot of use cases which are available. So examples and help is available. So if you're coming from the business background, think through that, okay, how you're going to solve a particular problem statement. Assuming that you have got a dev team, assuming that you have tech team available with you, how are you going to guide them? So that can be one dimension. The other dimension could be, and I know that most of you are coming from the development background, so you are already writing code, or you are a student and you are already uh, exploring the world of coding. So it is important that whatever we are learning now, we convert them into a source code. right? And of course, we have got all these LLMs in place. You can take their help to generate the code. And I think mm, to the best of our understanding, we know that this is how the code will be developed henceforth. And there is no point that we develop the source code, we develop the code, or we develop an application or a program from scratch. We all understand that it is going to be driven through LLMs. But at the same time, how do you make sure that the code that you're generating, it is delivering the output? Right? How are you compiling them? How are you putting them, and how are you integrating them? How are you creating a pipeline? And pipeline, when I say this, think about a larger system. Whatever we are doing is a subset of a larger problem statement, which softwares are the systems that already have been created, they are trying to solve. So say, for example, in case if I pick up uh, Agilix, right? Some of you are coming from Agilix, right? So there is already a software which has been written, and there is a user community. There is a consumption which is already happening. So when we are developing these programs, they are going to sit somewhere in the Agilix system, right? Now, so this is where we want to make sure that we are developing components that can actually go and fit into those pipelines, so that we get to know that, okay, what are the real kind of challenges that we are going to face, and how are we going to solve them. The same thing is applicable for other domains as well, and the same thing is applicable for those who are in the college as of now, right? They have to think through that, okay, this is not a standalone system that you are creating. In fact, AI, to a very large extent, is dependent. It is dependent on the vertical, is dependent on the domain. Right? AI, our technology is always an enabler. Right? So we have to understand that there will be a problem statement which is driven by the domain. It can be retail, it can be manufacturing, right? And already there are systems would be running. So how the piece that you are writing, how it is going to fit into. So say, for example, uh, and this is what we're going to discuss in today's conversation as well. So in case uh, if you have got a, e-commerce website, right, and you are on this e-commerce website, you are selling the products. So we can safely assume that this e-commerce website is already in play. There are customers, there are products. So I mean, you have got sellers, you have got buyers, and then there is an enabling system where inventory, the taxation, everything is taken care. Now, the kind of problem statements that AI team is expected to solve could be, there can be many. I do not want you to restrict your thought process around what I'm sharing. But maybe one of the use case could be, how do you analyze the quality of the products that that are available on your e-commerce website? How would you do that? And one simple example could be that you probably will go through the kind of feedbacks that the users are writing when they are purchasing a particular product. So in a way, what we are trying to do from AI standpoint, we are going to measure the sentiments, right? Now, this sentiments, again, as I'm saying that it's a part of the pipeline. It's a part of the a bigger problem statement that has been given, and uh, to a large extent, that workflow, that pipeline, what I'm referring to, the process is already, the technology already has taken care of it. I mean, the solution is already available. So you are kind of providing a value add, right? So the core business is that how you make sure that, okay, the products are available on the website, how people can buy them. Those are the core functions. Understanding the sentiments is kind of a value add. This is how the world has been seeing some of these latest and greatest which is coming in the AI world. However, now there is a tilt that People assume that these are the essentials. Anyways, so coming back to the point here, when we are working with LLMs, when we are working with agentic, you got to know the concepts which are there in ML, DL, right, and NLP. So this is how the structure has been developed, right? And this is a natural progression, as you may see. Machine learning is more about pattern recognition, and from pattern recognition to autonomous action. In between, we have got representation learning. How representation learning here means that how you simulate the functionality, how the brain works, right? Then we have got NLP, where we talk about how the language can be understood, and LLMs comes into the picture where the contextual reasoning is required. Anyway, so we spoke about the data, how it is spread, and NLP, specifically text. We know that a lot of data is actually available in the unstructured format. Of course, it's available in the structured and semi-structured as well. We also spoke about that. Okay, what NLP means, right? So let me ask a question here. Can somebody explain? Can somebody explain what this particular image is representing? Anyone? Dheeraj,
Uh,
Lakshya. Yeah, please go ahead.
yeah, I think according to this image, what I can see is the natural language processing. What it does is the like type of data which we give to them, like it is structured, unstructured, Excel format, and it convert to the understandable like human communicating language, like that can be easily understandable by the human. That is it's.
Yeah, yeah. Uh, Perfectly summed up, Laksh. So this is when we are dealing with a computer, or uh, or when you're dealing with the softwares, right? They don't understand the language that we speak. So NLP sits in between the humans and the computers, and their primary purpose is to understand what humans are sharing with them, and and again, what computers have understood and what is the output, they convert back into a language which humans can understand. So that it has got two components to it, right? So we spoke about NLU and NLG, which is these are the two different components, subcomponents of NLP. And NLU is more about understanding the language which we speak, and NLG is more about how what computers have assessed, how do they do the generation out of it. So NLG and generative AI, they kind of, you can say that generate NLG is a part of generative AI. Now, when I say this, why it is a part of generative AI, why it is not completely generative AI, that can be your initial thought, that okay, in case if the computers are able to generate language, or they're able to generate content, why they cannot be it is not considered as generative AI. I mean, of course it is a generative AI, but it's a subset. Why it is a subset? Because generative AI is not only restricted uh, to text. It is actually the literal definition of generative AI is that you should be able to generate multimodal output. And when we say multimodal output, it can have text, it can have images, it can have videos, and so on, right? So but here we are talking about only the textual part. So we are not talking about images, we are not talking about videos or any other model that can be generated. That's why NLG is actually subset of generative AI. Okay, so this is what we did. We also spoke about the different use cases that we have, and I think NLP is pretty much into everywhere. Um, Everything that we are doing, every software that we are using, there is a possibility either it has already been integrated, or there is a possibility that there can be something that can be done around it. So we spoke about the assistant, Siri, Alexa, Copilot. I'm sure that one of these you are using on a regular basis. And then Hugging Face, some of the algorithms which are again which are very dominant as of now, considering AI world. They are available on Hugging Face. I think we'll have a specific conversation around Hugging Face, where some of the uh, some of the algorithms which are available, we can speak about them, how to consume, and what is the advantage of them. But that can be done in a separate conversation. We also spoke about how this industry is expected to grow. It is a pretty solid growth that we expect to continue in NLP. And in case if somebody is looking forward to build a career in NLP, um, it's a good place to be in, right? And I also shared that a lot of people who are doing PhD, and it is uh, across globe. Not I'm not talking about India as a geo. Um, have interacted with some of the people in US as well, and Europe. They are doing different things. They are exploring sub branches of NLP, and they are doing PhD in that. I think it's going to continue as a very interesting research field for at least for the next 10 years, maybe more than that, right? And then we spoke about the different use cases, virtual assistant, sentiment analysis, and so on, right? How this overall 21% are how the overall market is divided. We picked up healthcare as a domain, and we spoke about some of the use cases which where NLP can be consumed. Right. I am not going into these details now. Then we spoke about why NLP is difficult. We spoke about some of the obvious challenges. I saw the man with the telescope. It's such a simple sentence, but it can have multiple meanings to it, right? We spoke about that, and of course the variations, the way we speak English, the way we speak any language, and the kind of mix that we have, multiple languages put together in the conversation. Hindi, English, and in case if you know any other language, say Tamil, Telugu, right? You can probably do a mix of all these three. So how does the system will interpret it? And now with Gen AI, Gen Z, they are also using different kind of words to represent different meanings. So how that can be consumed. So I think NLP has got a lot of challenges to solve, and they're doing it. So we spoke about all these challenges like lexical, where words can have multiple meanings. Syntactic, a word, a sentence can have multiple meanings. So how do you decipher that? Then the semantic one, a particular word can have different meanings depending on the context. Pragmatic, difficult to understand whether it is a sarcasm, it is a yes or no. And we picked up this example. We'll keep your proposal in mind. It is a no. However, it is sounding very. It, uh, the sentiments are not negative. At least we can say that, right? And then we spoke about the discourse. So sometimes it is important that we go through the dialogues, multiple dialogues to understand what is being said, rather than relying on a particular sentence. So the put together, these are the different challenges that we saw. And then we also spoke about very quickly about the NLP history. It's been there since ages, right? And we spoke about how actually the progress that has taken place. This is the place where we wanted to spend time, right? And I think this is something which I ran very quickly in the last conversation, but we can pause a bit, because this is where I'm expecting that the problem statement that we are going to share, we are going to discuss. This is where uh, you all will be spending time, right, and try to solve the case that will be provided to you. So, if you look at the overall NLP process, it starts with data acquisition. So, and then it follows through this pipeline. So, after data acquisition, text cleaning, and text cleaning is very important. because I think when you're dealing with the textual information in say some kind of commentary, even the feedbacks which are given on any website, and most of the times you may see that it is the feedback analysis that you are doing. So feedbacks when they are given, if it is in the textual format, you can expect a lot of spelling mistakes, errors, and all, right? So a lot of junk you can expect. So text cleaning becomes very important. Then you do pre-processing. We'll talk about these aspects, right? So we also spoke about the that what is the oral process that we follow, right? Data ingestion is very straightforward. Then we spoke about the text cleaning standardization, which I was talking about. Tokenization is something that we discussed in detail. Stemming, lemmatization, stop word removal, right? And then followed by the other steps. From business perspective, we very quickly discussed, because not many people are from the business background here. However, in case if you are, and of course, you can always rise in this particular space. You can pick up the space and be an expert here. So it is important that when you are dealing with the data acquisition, it is important that you know some of the do's and don'ts. Uh, there are a lot of malpractices which are happening. The data which is being uh, taken from the users directly, indirectly, it can be used for multiple purposes. So it's important that you follow the ethics, you follow the boundaries. In case if you are using a particular data set, um, you have the consent from the users that this data can be used, right? Tokenization, we spoke about that. Tokenization, and this is where again the point that I raised, that when you are dealing with LLMs, the unit of measurement or the costing unit is actually a token, and the token is in LLMs is at a subword level. So transforms rapidly, some of these examples that we discussed, and this is how they are broken. Rapidly will become rapid and ly. So it is like uh, if we are using 7 to 8 words in a sentence, they will translate into approximately 10 tokens, because some of these words are going to get broken into subwords. Uh, and that's why the cost, some of these startups who are using LLMs very extensively for everything that is required, where the AI cross is required, they're using LLMs, and their LLM bills, the consumption is is difficult to control, right? So that's why they are going to the standard practices, where they are trying to bring in machine learning, deep learning algorithms, and trying to solve some of the problems that can be solved using these algorithms, rather than going into LLM for everything. So this is the point that I was raising. I hope we are able to connect to it. Stemming was more about reducing the words into their shorter variations, or maybe in case if you are using running, how do you convert this into run, right? Into the standard form. So these are some of the examples that we discussed. And of course, you may see that there are some spelling mistakes which are actually taken care in the lemmatization, where we understand the meaning. We understand that these words are a part of speech. Again, when you are going through the contents, please spend time on understanding bag of words and part of speech. How do they work? Uh, One more thing which I would suggest, when you are doing some studies, your own research, uh, the way the sentiment analysis is done around 5 years back, and the way it is being done now, what is the difference? How the organization, because Amazon in particular, at least that's one example that we can take forward. uh, Sentiment analysis, organizations like Amazon, they had solved it. The efficiency can be challenged. the quality can be challenged. You can say that, okay, out of 1000 different feedbacks which were coming on Amazon, maybe a few of them the system was not able to qualify. Sorry for this. Just a second. Let me put my phone on mute. Yeah. Yeah. Okay. Yeah. So no, I was referring to Amazon and the sentiment analysis. So you probably have to spend some time understanding how this is being done, how this was being done rather, and what are the techniques that have changed now. What is the different quality that has been brought now? Right. So it will help you to connect what kind of effort has been done in the past and what is that we are doing now. We also spoke about the stop words, right? Some of these words like is, the, and, of, to, a. I mean, some of these words they do not carry any meaning. Lot many times, and the traditional process where you work on NLP, you get rid of all these stop words. You focus on the words which are important. Say, for example, if you are using this particular sentence has been passed to you, the cat is sitting on the mat. After removing the stop words, it is cat sitting mat, right? So three different words. I mean, all other words have been removed. So this actually kind of reduces the first of all, you are able to focus on the keywords which are important. That's one. Second, the kind of processing that you have to do, that also reduces. So it is effective both ways. However, there are some flip sides to stop words. So, say for example, negation, particularly not good. In and you are if you are taking off stop word not, then it becomes difficult to understand eh, uh, what this particular feedback is all about. And this is where the large language models, they do not remove the stop words. So they work on a different the way they have been trained. They actually have captured all the data, and whichever is available. And we'll talk about how the different sources of data has been gathered in LLMs, but in the session to follow. Uh, and whatever the data was available, of course, they would have done some pre-processing. They would have done uh, uh, correction the data. They would have removed the junks, but that's a separate thing. But they have not removed any kind of stop word. So this is, then we also spoke about named entity recognition, which has got a separate segment in within NLP. This is where within a sentence, if if there are any nouns that are used, whether it's the name of a people, organization, locations, and dates, right? Named entity recognition comes into the picture. We spoke about normalization, where all these things are put together, uh, where we are talking about lowering the case. We spoke about removing punctuation, expanding contraction, and I mean, don't become do not. So amazing becomes amazing, but without exclamation, and so on. So this is something which we already done, right? So, and this is a difference that we try to share discuss. When you are doing normalization, we did normalization in machine learning as well. We did not do normalization in deep learning, right? And we also spoke about why normalization is not required in deep learning, or why we cannot do it. Anybody who can recall it, why normalization is not possible in deep learning? Anyone? Dheeraj, Laksh, Muskan, anyone? Okay. So Are you able to recall what we did in deep learning? We were dealing with images and primarily the kind of use cases that we discussed, they were revolving around an image. And in case this is the example that which I shared as well. In case if we apply any kind of deep learning algorithm, deep learning techniques here. So say for example, in this particular video which we have, right? Um, we want deep learning to uh, share more details. What is happening? I mean, just a simple image which is given, and it you are asking that okay, please try help us understand what is going in this image. So when deep learning techniques will come into play, uh, most likely they will try to divide this into multiple parts. One, where probably this overall text is being shared, right? In case I'm not sure what kind of window you are into, but in case if there is a video or the image of the speaker which is in front of you, I mean it will try to pick up that okay, there is somebody whose face is seen in the image, and there are list of participants, list of the name of the people, right? So it will try to decipher what is happening. Now this is something, uh, in case if you have to, as a human, you want to normalize that, you cannot do it actually, right? You will not be able to pick up an image and qualify that okay, this part of the image is important, this part of the image is not important, and this is how the particular image needs to be enhanced. You cannot do that, right? When you're dealing with supervised unsupervised learning or NLP, the data that you're dealing is something which you can easily manage through some of the techniques, and that's why the normalization is possible when you're dealing with ML techniques or NLP, but it is not possible when it comes to deep learning, because the kind of data that you deal is you as a human you cannot play around with it. I hope this is clear. Normalization is more about standardizing the input that is going into the pipeline. The problem that you're solving, you're trying to standardize it. And when we say standardization, it can be in terms of numbers, it can be in terms of the quality of text, removing certain things, and making sure that um, two different words, the way they are represented, they are coming together. Say great and great, GRT and GREAT, right? They are the same words. So that's the primary purpose of normalization. Okay, I please spend some time, go through some of these techniques. Uh, it's important that you understand, and these are not so difficult, but when you try to build your own programs, when you try to solve certain use cases, um, your understanding on these techniques, uh, and some of these can be overwhelming because there are a lot of concepts. But the moment you are going to put this into practice, your understanding on these concepts will improve for sure. Okay, so then let's talk about vectors. See, this is something which we have already discussed up till now, right? So that's why I actually ran through the slides very quickly. And this is when we are talking about vectors, this is a I think this slide we had not covered. So this is a new concept that we are bringing in. Now, as you may see, there is something that there are a few things which are represented on this slide. But if I pause for a minute, right, and try to understand what are vectors, and vectors are something that we we would have studied in school, colleges, um, maths, physics, right? In case if you are not from maths background, if you are not coming from physics background, I think then it's a different thing. But otherwise, you in your academics, you would have gone through some of these concepts. In fact, when we say it is not even 11th or 12th, it is the vector starts somewhere in around uh, 6th class or 7th class, maybe when we study MK systems, when we study velocity, uh, and 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 the reasons are very straightforward. The difference between speed and velocity, if you can recall, one of them is a vector, another is a scalar. uh, so at least the acquaintance of this word vector, we have done in the past. We know it was there in the academics. So what does vector represent in NLP? Mm, So vectors in NLP represent that a particular word, how it is being represented in numbers. Uh, we know that the words cannot be understood by the system, by the machine, by the computer. So what, how they are going to understand it? They're going to understand a particular word in terms of numbers. So say for example here, the cat is being represented as 0.25, 0.81, and -1, minus 0.1. So some uh, 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 number representation, and which has got meaning as well. It is not that it is something which is very random, right? So vectors come into the picture when a text needs to be converted into something which can be understood by the machine. And they're very important because this is kind of the basis on which the NLP thrives. So what it does generally, and if you can look at the kind of different properties, it is, we are talking about dense, we are talking about semantic similarity, context aware. So these are the three different properties that we are speaking about. But let's understand what does that mean. So when we are talking about a context, um, and when we are talking about say you are going through a story, right? The contents, the sentences will always be interconnected, right? uh, and this is how you will understand what is being said, right? There should be some kind of similarity between the words. Say cat and dog, probably they they will be categorized into a particular category. Maybe they are representing animals. Whereas in case if cat and car, though they have got same number of alphabets, and only a minor rejig has happened, but cat and car, intuitively you probably say that okay, maybe these are similar kind of words, so they have a similar kind of vector. But that's not how it is going to play out. Cat and car are two different objects, and there is no commonality between them, so their vectors are going to be very different. And when it comes to the latest, the techniques that we use in NLP, we use more and more dense vectors. So uh, for example, man and woman, they will be categorized, they will have similar kind of vectors. So maybe if cat is 0.25, 0.81, -1, zero point 0.1, the dog probably will have 0.23, 0.82, and similar kind of numbers. So that when they are kind of getting clustered together, right, when they are going to get grouped together, it is easy for the machine to do it. If the numbers are very different, it is going to be big, it's going to be difficult, it's going to be a challenging task, that how you cluster them together. And this concept this concept is very critical when it comes to understanding of the context. Where are you coming from, right? The kind of relatability, how these words, how these sentences are um, uh, they have got a kind of a connection, right? Uh, some of these jargons which are written on this slide, cosine similarity, semantic similarity, I think this would uh, require some thought process at your end as well. Cosine similarity is more of a mathematical driven approach where if you, I'm sure that you would have gone through the trigonometry as a subject, right? Where uh, uh, tan theta, cos theta, sin theta, right? Some of these concepts you would have studied. Cosine similarity is actually being driven from there, and it helps you to identify the similarity between two different sentences, two different words, or two different paragraphs, right? Uh, but again, these are more from understanding how, or maybe if I take it back, take a step back, it is more from the mathematical background that how some of these words, some of these sentences are going to get grouped together. But for the time being, and when we do the implementation, you will have a better understanding. But please understand that vectors are primarily, uh, in a way, they are the kind of the they're at the heart. They are the essence on how the words, how the sentences, they are kind of deduced, they're kind of understood by the machine, and how they're grouped together, uh, how similarity is identified between them, and how the meaning making can be done. So this is about vectors, and you would have also would have heard about word embeddings. And word embeddings are nothing but dense vectors. Again, they are vectors where similar kind of words are grouped together. Here you can probably see king minus woman is equal to queen. A poor representation, but this is how the computers would work. They will understand that okay, when we are dealing with king and queen, they are kind of same. What is differences? Maybe king is a man and queen is a woman, right? And when it is going to get converted into vectors, king and queen will have similar kind of vectors. They will have similar kind of, not identical, but similar kind of numbers. So these are the two different concepts. Uh, we probably have to spend some more time. Um, you go through some of the text. I'll share you some of the articles for you to understand in much more detail. But these two concepts, vectors and embeddings, they are kind of the basis of how NLP works. There is one more thing which I wanted to share, that using the word embeddings or the vectors, the pattern identification is done. So when we say this, uh, uh, and we will talk about this in generative AI LLMs as well. So if you can see this, what is happening here? Uh, this particular GIF, which you can see, uh, three different words are taken into consideration, right? And on the basis of this, what is happening? There are two different techniques here. Um Unfortunately, I cannot pause this, but the first one is wherein the two words, there are three different words which are being given to the algorithm, and it is able to identify, okay, what is going to be the word in between. So they say, for example, brown fox jumps, right? What it is doing, it is picking up brown and jumps and predicting that, okay, maybe it is going to be the fox in between, right? And when you are picking up these patterns, it can be in the form of bigram, trigram. Generally, it is also called as n-grams. So maybe picking up two different words together and trying to find a pattern. Maybe picking up three different words and trying to find a pattern. Uh, Let me ask a question here. And I know that these some of these concepts are going to be a little difficult to understand. But if you stay with it, I'm sure that you will be able to understand and implement. But anyways, let's try to pick up a particular point here. You know how there are tools now available that can help you to identify plagiarism. Anybody who can give a shot and help us understand how plagiarism can be identified in the text? Anyone? Lakshya, you want to try it?
Okay. Once again, okay. Well, it's basically how you can, like, if you have a certain text and then you can compare it with an existing source to check similarities, or if there's a, previous material that has been given, like that. Because for us, when, like, in training and placements, they do a lot of plagiarism checks. So here they use certain tools like dupli checker, or certain tools that have been made for plagiarism, which will automatically catch if it can actually understand if it's copied or not. And here what it does is, it actually the report, what it shows is how much of the content has been actually plagiarized, and where we can improve so that we can reduce the risks of plagiarism. This is like how it's done in our thing.
Absolutely spot on, Lakshya. Uh, I think why I picked up your name, Lakshya, because you are going through this process in your college where you are submitting thesis projects, right? And all the colleges, they have got this checks, these checks in place now, that if a particular thesis is submitted, a project is submitted, it goes through plagiarism test. And plagiarism here means that uh, um, if you have picked up a particular content from a from some source, right, it is copied. So that is plagiarism, right? However, let's extend this conversation. Let's talk about uh, now, apart from plagiarism, there are tools that can identify whether the text that has been submitted, whether it is computer generated. Now let's talk about this. Have you thought about it? How this is something which is done? How the system can identify that yes, this particular text is not human generated. It is computer generated.
Uh, yeah, I think what I think is, or what I read about that is, like, while it's checking the plagiarism, uh, if it is a AI created, AI generated or not. So this is just checked by the, like, vast database. Like,
Hmm.
if we can say about the OpenAI, so it can check its vast database, like the some of the keywords which were basically, like, check about some of the key points, like it is a AI generated or not. Means, like, some of the, I think, I can say, like, if any paragraph is generated by the AI, so it can check some of the key points, like related to, check from its database, it is related, it is generated by this or not. Like some of the techniques, like a difference between the human, generated and AI generated. So it can check from these key points if it is AI generated or not.
Yeah, 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 yeah. So I think I get your point, and this is sometimes this is one of the things which I understand is uh, uh, if you have to understand how or you have to detect a particular text, whether it is generated by machine, um, you need to probably go and understand the algorithms, how the text is getting generated. If you understand that part, converting or identifying a text if it is generated by a machine is should not be that difficult. There are tools which are available now. Quiltbot is one of them which I have used extensively. Now, this some of these services are paid. Earlier, it was pretty much free. It can be leveraged for plagiarism text and the test, and also for computer generated or human generated text. But now some of the services are priced. Now the point is that not many of these tools, they share the logic, what is happening behind the curtain, how they're able to identify that a particular text which is written or generated by machine, what is the kind of logic that they have applied. But if you understand this science, how the vectors work, how the word embedding is done, you should be able to relate that, okay, maybe using these logics, say for example, if you go through some of the content, there are some words which are repeatedly used in generative AI. Say, for example, unlock, incredible. Uh, some of these words which kind of generate a lot of interest. It raises the interest level in the among the readers, because the kind of elevated words that are being used. So some of these words you can easily see that, okay, these are generated by. It's not that you will not use unlock, for example, but if you look at the way some of the content which is available on LinkedIn or maybe advertisements, you will see a lot of times you will see this word unlock the potential. So I mean, the moment I see this, I know that okay, it is generated by AI. If I can do this, of course, machine can do it much better. Right. Now, this is only one pattern which I have shared. There can be many more. How the combination of these words, they come together and play a role. Say, for example, in case you are saying that okay, this is happening because of A, B, C. When you're writing as a human, you probably will say A and B. When you're writing as a when you're writing it, uh, you will say A, B, C, D all together, right? Whereas uh, whereas whenever you will see the text which is generated by any of the Gen AI tools, you will see lot many times it is A, B, C only. Try it out, and you will see this pattern in the text that is generated. Try to generate some of the code. Maybe you can write an essay and so on. You will see that when three different adjectives are being shared in the generated in the text, you will see that they are talking about attribute A, attribute B, and attribute C. Just a second, please.
So you're on mute.
Oh, I'm so sorry for that, and thank you so much for the correction, Laksha. Uh, Yeah. When we are going through, I mean, some of these patterns which I was sharing, right? I mean, this is something which is coming from the observation standpoint. This is not something which some of these tools who are doing this analysis and coming up with the results that okay, um, that this is a computer generated text, right? As I said, that they don't disclose how some of these tools functions, but it is easy to understand when you are looking from the vector standpoint, when you are looking from the word embedding standpoint, because probably the content that is generated, you can see that okay, the usage of some of these vectors, they will come together: vector A, vector B, vector C, right? And when these tools will identify that okay, these three vectors which they know that uh, uh, would have been used in generating the text, right? If they are trying to they figure it out, okay, these three vectors are coming together, the tool will be able to call out that yes, it looks like this is it's not human generated. And it is not about the mistakes. Lot many times what I have seen is that people will generate some kind of text, right, and before they post it on any other social platform, they will try to introduce some mistakes. Maybe as a human we would think that okay, oh, there is a mistake, this is inappropriate use of noun or a particular verb, and you may then discount that individual that okay, oh, at least it is not human, it's not computer generated, at least the person has written so. But that's not the case. These tools will still identify that even if you are introducing there are the mistakes in the text that you have generated, it will still identify that yes, this is it is generated by by the computer. So again, the reason why I'm emphasizing is that these patterns uh, uh, and these identification, whether it is generation of text or it is identification of text, whether it is generated by human or machine, vectors play a very significant role in that. Now, very quickly, and this is where I want you to spend time in this week. I want you to build a sentiment analysis engine. This is probably one of the simplest possible solution that you may find in the industry, and there will be a lot of help that is available. A lot of solutions which are there in the market. Um, the moment you Google, the moment you do Chat GPT, you will figure out some solutions which are available, right? So I do not want to go into the how you're going to write the code, right? I think that you can do it. I am pretty confident about it. But I want you to focus more on the process that is being used. So what we will do in the next 30 minutes, we'll walk through how a particular use case, how a particular problem statement is solved, right? What can be the approach towards it? And then you go back uh, and you will write the program, how the sentiment analysis can be done. I'll provide you the data. I'll provide you the feedbacks on which you can apply sentiment analysis, right? But the code will be generated, will be done by you, right? And when you come back into the next session, I'll request some of you to come forward and present what you have understood, right? And show us how the model is working. Is that okay with everyone?
Yes, sir.
Yes, sir.
Are we good?
Yes, sir.
Okay.
Yeah.
Yes.
Okay, sure. And again, so some of you who are coming from business background, and I think probably I can address to Mushtri and maybe Yogita, you too, because your role is kind of elevated one. So you can you can spend time on qualifying the business problem statement. You don't have to really go into the coding side, but how are you going to solve it? And maybe you can take a parallel example, whatever is applicable in your organization. So say Mushtari, in your organization, maybe some of the feedbacks which are coming from the users on the kind of services your organization is providing, right? uh, and you can get into that hypothesis mode, right? Similarly, Yogita, maybe you can think about if there are any kind of feedbacks which are running around Agilex, or maybe the kind of challenges, the kind of issues that we see in the commercial insurance space, right? Maybe you can start thinking about how these models, how these problem statements can be solved. So I'll quickly go through the this problem statement and help you understand how it is solved. So yeah, so this is a case study, right? And some of the concepts that I want to introduce to you, wherein you will understand that okay, when you are talking about a use case, um, what are the kind of details that we need to take care of, right? So here we're talking about a customer feedback system, right, which is for an online retailer. we I and I have picked up this because it's easy for you to understand, connect to, right? And so uh, we were trying to help one of, and this is a real scenario. Uh, um, um, if you know an organization, First Cry, uh, have you heard of it? First Cry.
Yes,
Yes,
sir.
sir.
Yeah. So First Cry, when they started their operations, I think they were instant hit, um, and they were very well received in the market. And I think they're doing pretty good even now. But they had some challenges once they reached to a particular scale, particular level. Um, that's where the feedback actually started getting impacted, right? So you can assume that the company has launched itself, the products are there in the market, there is a user community also who are actually interested and they're buying products from First Try. And now this particular situation is happening where uh, the online retailer is receiving thousands of mixed customer messages daily, right? They're kind of getting the reviews, the chats, right? And NPS is about net promoter score. So net promoter score is a representation, is a business metric. It represents uh, how good is your organization when it comes to handling customers, right? It's an index on a scale of 10. You can measure the effectiveness of an organization, right? And there are two more parts to it. There is something which is called customer acquisition and customer churn. So customer acquisition is, when we talk about customer acquisition, we it's the amount of effort or the money that you have to invest in order to bring one additional customer into your system. So in case if you are in the retail business, um, you have a shop, right? Getting a new customer can be seamless. But in case if you are in the space of B2B, business to business organization, right? Um, say again, services. If we take up example where mostly you are operating, getting a new customer on board is pretty difficult. And the same thing can be applicable for Yogita, you too, right? Because your organization builds different products now, and those are not that has got a very niche market, right? It is not a retail one. So procuring a new customer will cost you a lot. And at the same time, in case if we lose a particular customer, you may have seen in your organization that how much how much impact it actually brings into the organization. The escalations, the senior leaders will come into the picture and so on, right? So customer acquisition is when you run a process and you acquire a customer, and customer churn is when the customer moves out of the system. And uh, the customer churn is very, very important for any organization to tap. So what does that mean? That in case if customer is coming into the picture, you want to do everything that is possible to make sure that the business is retained with that particular customer. And that's where in case if the NPS is on the lower side, that's an indication that okay, the customer is not going to stick for long. But again, depending on the kind of nature of business you have, if you are dealing, you are a retailer, you probably may not care though that much. But in case the kind of business that we are in, specifically in IT, we are very much concerned about it. So NPS becomes important, right? And negative feedbacks for this particular organization, again, they were done in a manual way, and it was seen that the net promoter score was dipping. So this is where this problem statement came to us, right? And so what we did, this is the standard response that we had, right? We wanted to make sure that the feedback, we should have the capability to divide this into different categories: positive, neutral, and negative. Uh, Negative is the place where first cry was very focused on, right? More than positive and neutral. And of course, they wanted to make sure that we are understanding the neutral sentences in a better manner. Um, Now, if I look at it, the goal that we have shared here, if we do this in the current context, what I would expect is that the feedback can be divided into three different categories: customer, I mean, positive, neutral, and negative. In case if it is negative, now because of agentic AI, I will expect that a ticket should be created for that particular product. Maybe it can be a Jira ticket. It can be, again, depending on the kind of workflow that you have, right? And in case if it is a negative sentence, a sentiment, I really want my team to work upon it, right? And that's where the agentic AI can come into the picture. They can create some kind of tickets. They can also help you to figure out that this is a particular sentiment which needs to be handled by team A, team B, team C, that kind of intelligence, right? And in case if there is any kind of problem that was solved in the past, the agentic AI can go to that extent that it can assign to the team or it can assign to that individual. So you have, when you are thinking about agentic AI, sorry, I'm jumping the gun here, but we have a case where the agentic AI can come into the picture, the automation can come into the picture, right? So when you are thinking of some of these problem statements, please think through that. Okay, you have solved a part of the problem, but what do you do with it? How do you ensure that this your entire pipeline, there is some value that you are generating out of it? Anyways, coming back, so the problem statement that was given to us was this: we wanted to build two different models. Now, uh, these two models, why these two models were needed? Because one of them is kind of instant. So say for example, somebody calls you, calls first cry, or maybe the organization that you have got a contact center. A customer calls you, and the agent picks up the call, and now the sentiments needs to be measured then and there. So it cannot go through a offline system. It cannot be done in a batch mode. So it has to be done instantly. So that's where we needed some kind of algorithm which is lightweight in nature, and that's where we applied. We went with the classical approach, TF-IDF. We'll talk about it, and logistic regression combination, right? However, we also wanted to do a batch processing where some of these feedbacks which are given by the customers, they can be processed in batch. So I hope you are understanding that there is a live system where you need to measure the sentiments. Like this, the conversation that is happening between you and me, and imagine that there is an indicator at the top of the screen uh, stating that, okay, this is a positive sentiment, this is a negative sentiment. So it's happening on the fly, right? Real time. Whereas uh, we are done with this conversation. Now this conversation has been recorded. After some time, teams will process whatever has been spoken, and it will come back with a result that, okay, out of 10,000 different sentences which were spoken, 9,000 sentences were positive, 1,000 or maybe 500 sentences were neutral, and 500 sentences were negative. So it is done in a batch mode, right? And when you are talking about batch mode, you expect it should have a higher level of accuracy, and a lot of computing will be required. So that's why we had two different approaches to deal with the problem statement that was given. I hope we are connected so far with this problem statement. There is no question, or maybe there is no confusion around it. Are we good here?
So,
Okay. Let me take you to the next slide. Yeah. So this is a typical feedback, and it is when you are providing it to the system, uh, um, because it's more about regression technique that we were trying to apply. And regression would mean that it is kind of a labeled data. I hope we are on the same page. We are bringing the machine learning techniques into play here. So that means that the data, the feedbacks that has come from the customers, we have labeled it that it is positive, it is negative, or it is neutral. Correct?
Yes, sir.
Yes, sir.
Okay. So here there are three different examples which I have given here. Loved the product, positive. Customer service did not resolve my issue. It's a negative one. The app crashes sometimes, but features are good. Now again, it can be, you can say that okay, it's a negative comment, and it's completely fine because the process has been executed so in a such a manner that it is getting into the category of neutral one, right? Again, how the label annotation has happened, are humans who were involved, they were trained to put this into neutral or negative category. So let's move on. So this is the kind of data that you have. And then we these were the different sources, and this is something which you need to think from the solutioning standpoint, that let's get the data as much as possible. The more the data, the better chances are that you will have a better control. So product reviews were taken into consideration. Support tickets were taken into consideration. In case if there is any kind of chat communication which is happening on NPS or CSAT. NPS is Net Promoter Score. We have already discussed. CSAT is a customer satisfaction score. So again, I mean, they are the same thing. Just they are synonyms. So in case if you see NPS, if you see CSAT, you should consider that okay, we are talking about customer sentiments. And of course, these days, a lot of media, a lot of people will go onto the media, social media, right, and they will share certain things, feedbacks. So you would have seen that how prompt some of these organizations are when there is a complaint which is done on Facebook or Twitter, right? They respond. So we have gathered that data as well. And voice transcription is again an important aspect. Voice transcription comes into the picture when it, I mean, you understand that okay, voice transcription is how the communication between the agent and the customer is happening, converting that into the text and feeding that text into the sentiment analysis engine. Now, some of the checks maybe we have already discussed, that whether you have taken a consent, do you have the clearance, maybe the kind of the when customer is onboarded, organizations actually put all these clauses, so you are covered from that standpoint, right? uh, then when you're dealing with this kind of problem, another aspect that can come forward is that when this particular feedback was given, so timestamps comes into the picture. For which particular product, is it only related to a particular product, or it is actually happening across board, right? Which region this feedback is coming from, what is the language that has been applied, whether it is English or maybe some local language which in which the feedback has come, right? And again, as we see, that particular app crashes feedback, right, it was put into the category of neutral, whether the human labeling is done appropriately, right? um, so that comes in the label reliability, right? So these were some of the checks that we had. One more example, one more problem statement that we had was that you would have seen that when the sentiments or the feedbacks are given, they are you rate a particular product in stars, right? Star of 5 star, 4 star, 3 star. This is the standard way how the rating is done, whether it is a product which is available on e-commerce, or whether it is about say tourism industry, hotels, and the ratings, the trips. So because putting the stars is relatively easy, and but again, when you are trying to understand how these stars should be represented in terms of sentiments, you need to be cautious around it. So when we were trying to do this, we assumed that okay, 4 to 5 is positive, 3 is neutral, and 1 to 2 is negative. But it was pretty regular for us that though we are converting these stars into positive, neutral, negative. Uh, there are cases which you will see very often that maybe somebody would have given you a rating 2, but the feedback is it's a good product. Now the rating in terms of stars and uh, and the feedback, they don't align. So how do you deal with that? I mean, such kind of challenges we had to take into consideration. Uh, okay, so this is the process that was followed. I hope you can understand that this is something that which we went through. We dealt with normalization, tokenization, stop words, stemming, right? So when you are going to work on this problem statement, the data which I am going to provide to you, or maybe you can find the data on Kaggle on some other source as well. These are the mandatory steps that you will normalize the data, you will do the tokenization, you will make sure that the stop words. Uh, you can take a different approach. You can say that okay, I'm not going to drop the stop words, but please, when you are doing this, try to understand at your end why you are not removing the stop words, right? Then the stemming and limitation. So in a way, you will do the normalization of data, something which is completely onto you. We applied different. So these are the different techniques which I shared, right? That we applied bag of words, TF-IDF, right? So this is where traditionally what has been happening, that each of the organization, what they will do, they will create a corpus. Now the corpus, the word itself has got multiple meanings. These days, when you are talking to somebody who is into the financial industry, if you say corpus, it is about the assets that those individuals have. It can be money in the bank. It can be the physical, I mean, land, property, and all, right? Put together, that becomes a corpus. However, when it is about NLP, when we talk about the corpus, we are talking about the number of words that the organization has in its repository. And when they are trying to create this corpus, they also qualify that okay, this particular word has got this much rating or this much weightage. So this is how they create a particular corpus, right? Now, the corpus is also something which is available. You can download it, but it is going to be very generic, right? So say for example, again, if we pick up Yugita and team, maybe the corpus should be related to commercial insurance space. It can have a generic availability, but maybe certain dimensions needs to be domain specific, and that's why the company they started creating their own corpus. And this is what I want you to study when you are going to understand that how some of these problem statements were solved 5 years back, and what actually has changed in the recent years, right? uh, Again, this is very important because when we are going to implement some of these solutions, uh, that thought process will help you a lot. Okay, so bag of words, we have spoken about, right? And TF-IDF are vectors. Word embeddings are again vectors, right? Transformer and sentence embeddings, these are the latest approaches, which is available after 2017. We have these special vectors, special implementation of neural network, which are transformers. But I'm not going into the detail of transformers, though you can study at your end, because we are going to have a specific conversation on transformers, how they work. Uh, a dedicated session only on transformers, because they are kind of, they will connect the NLP with your LLMs. So that is a kind of a bridging that we will use. So again, this is how we did it. Now, how you do it, it is completely up to you. Again, as I said, this is the real time, the one which was a classic one. It is a lightweight one, and uh, the results are quite instant, and that's why we used it for real time. It may have a low accuracy, but when we used the one which are much more effective, they were done in a batch mode. Uh, okay, then when you are developing this solution, it is important that you call out that okay, how are you measuring the quality of the solution that you have created, right? So what I'm going to do, I'll share this data set with you. Let me bring it up. Mm, okay, yes. So this is the data set that we have, right? And it has been labeled. Now what I want is that you create a model using this data set, generate a code using LLMs, but make sure that you understand the meaning of each and every line. So that's one. Uh, I'm sure that you generating a particular model would not be so difficult for you, but then you need to interpret it. You need to understand that okay, how are you going to call out the quality of this model that you have developed? And, and trust me, developing a model will not take more than say 30 minutes for you. Though understanding how this code has been developed may take another 2 hours for you. That's pretty much understandable. However, the larger challenge would be that if the accuracy is 80%, whether it is good enough, right? And that's where the confusion matrix comes into the picture, right? I'm throwing these jargons, but I really want when you come back in the next conversation, you talk about uh, that how good is your model, right? How good is your model? There is a background. Sorry. There is a background. Can you go on mute, please? Uh, can you go on mute, please? Uh, just a second. I probably have to. Yeah. Okay. Sorry. Yeah. Sorry for this. So this is the data that we have, right? Again, and if you can see that, okay, this is a title which has been given, and it is kind of optional. There is the detailed feedback, and then we have got the stars as well, right? And it is again, this is a feedback which is available for Amazon, and it's a real time data. So it will have all the nuances, lot of all the challenges that you otherwise also would face when you are working on a real problem. So it has got product detail, it has got a labeling already done. So based on this, you will develop a model. And what I suggest you is that um, the accuracy needs to be calculated, and then the solution should be developed in a manner that in case if you're adding if you're feeding in one more feedback uh, into this pipeline, how that feedback will be interpreted, whether it is neutral, positive, or negative. So we need a real time implementation on this. Are we Have we understood this?
Yes, sir.
Is it difficult, easy, or maybe you want to take a maybe you want to go into this, and maybe in middle of the week you want to call out whether it is difficult or easy? Can we expect this to be ready by next week, by next Sunday?
Yes, sir.
Okay. And do you want to do it at individual basis, or you want to do it in a group of two? What will work? What is your preference? You want to do it at
Individual,
individual level? Sorry,
individual
Dheeraj.
level. Yeah, individual level, sir.
Okay, great. I think we should have enough time to have a conversation at individual level. Uh, so maybe we can stop here. Uh, and it's important that whatever we are learning, we do the implementation. So I really want some good coding to be done, and some good solutioning which you come forward with in the next session. I hope the problem statement at least you are able to understand. There are some topics which were difficult to understand. I completely get that. But in terms of the problem statement which we are supposed to solve, you are pretty much clear with that. All right. Okay. Then if that is the case, we can stop here, and let's continue to have dialogue throughout this week. Um, what is that you're doing? How are you progressing? And what kind of challenges that you have? We have not spoken about
Sure.
the accuracy part in a lot of details, and that is where I expect that you guys will struggle. So spend time on that. And in case if you want to have a conversation with me, please feel free to come forward and ask those questions. All right. Okay. So with that, we can probably pause here. We can stop here, and we will resume back on Sunday, next Sunday.
Sure.
All right.
Okay, sir.
Okay. Thank you so much. You have a good day. Thanks. Bye.
Thank you, sir.
Okay.
Thanks.
Bye
Thanks.
bye.
Bye.
Thank you, sir.